So yes, and put a second question after I made my presentation, or is Braille indispensable? And you see that this presentation will be by Dorine, Veld and Davy Kager, but there is no Davy Kager today. So Davy is a Dutch math, a student of computer science. He's doing a lot of math. He's also one of our customers. And so, yeah, he had exams and he couldn't come. So I represent both today. Now, the difference between the last presentation and mine couldn't be bigger. The only thing we have in common is about the use by adults and young adults. But it's we don't have a contracted Braille in the Netherlands. And we don't have a Braille code in the Netherlands. And this is where it all started. Dedicon, before I tell you about this, the resource center for learning materials for blind, visually impaired and other people with reading impairments. We also produce for the National Library, but let's not dwell upon that now. Let's quickly go to the Dutch situation about mathematics. Little history. In 2009, we introduced a linear math notation because we had no Braille code. There was a working group of math teachers who set out to kind of standardize the way that everybody was working. It was kind of a calculator language. It was done for primary and secondary education. It was not done for higher education, simply because the teachers were for primary and secondary school, and it was only for digital use. I assure you, you will go home puzzled and with a lot of questions. Okay, first of all, why only for digital use? Well, we have very small numbers of students, little more than in Iceland, as I learned today, where they have 3 every 10 years. Well, we have 3 every year. There is a wide geographical spread, and most of the students are mainstreamed, and this results inevitably here and there in a loss of expertise, especially regarding difficult subjects like mathematics or chemistry or physics. Other reason is all the kids work with laptops. There are no Braille certified teachers in the mainstream schools. And in the mainstream schools, there is also a belief that teachers don't really need to know Braille, especially in secondary education. Kids are supposed to be self-supporting. And nobody learned a Braille code. So that was the situation, and that is why we developed a math notation, a linear math notation for digital use only. It was kind of difficult around 2000, 2005. Typing was done with the QWERTY keyboard. We did not have Braille keyboards. They were not supplied, simple. The reading was done on the screen by the sighted teachers and pupils, and of course on the Braille display by the blind students. But what was displayed on the display was really a problem for both of them. As you now know that it's not a code. It was 5x space U trema. With 2 dots, 2 equals 2 space / do. Now what would this mean? This would mean 5x over, and then a line underneath it, 10 equals 10 squared. But nobody understood this. And this was a notation that was used to get the right Braille character from the printer. So this was not invented to make life easier for Braille students or teachers. So this is a real problem. What is it saying? It was source of errors and misunderstanding because the slash usually in calculator language means divided by, and here it would mean the exponent. Reading and writing are not the same. A lot of misunderstandings. It was a very confusing situation, and it was also a very discouraging situation for the students. So math became practically inaccessible. First, there were the reading, notation, and drawing problems. Then there were a lot of prejudices that math would be too difficult for blind students. Yeah, no wonder. What's the chicken, what's the egg? Blind students were actually actively discouraged to choose math back then. I can tell my son was told not to do math. Okay, that's beside. Okay, so a solution was needed urgently. Math is important. That's a general reason. It's a basis for logical thinking. It gives access to STEM students, for example, computer science, which is very popular in the Netherlands for blind students. It gives access to statistics, which is necessary in most alpha studies, language-oriented studies. Also, it was government policy, because there was a time where math was not compulsory, but back then suddenly it became compulsory. So we had a problem. Which way? Houston, we've got a problem. So which way to go? Should we reintroduce or introduce a math code, or should we improve the notation on the screen? Well, introducing a math code, the thing is, which one? We didn't have any. Do you go to Germany? Do you go to States? Do you go to UK? And why? Okay. If we would have to train the teachers or itinerant teachers to help the students. And in mainstream schools, there was a lot of opposition to using codes, because it's not communicative. And this is maybe something that, I know that's something that other countries may recognize. And also you need conversion software if you start working with codes. And as I said, the situation was very urgent. And this solution, reintroducing a Braille code, was simply considered a dead end. So then, improving the notation on the screen. So step one, we could develop a standardized linear notation for digital use. As you see the example I just gave you, you just, for blind listeners, notate it as 5x/2 equals 10 circumflex 2, meaning the same. Oh, sorry, It's easy to type on a QWERTY keyboard. It's easy to communicate. A sighted person can scribble in a spatial way, what is this saying? Because we all know it from the calculator, or from Maple, or from Mathematica, whatever. No conversion is needed. There are no problems when you are converting to Notepad or other programs, no squares. It remains consistent. And so the notation was implemented in 2009, and we had all the information on a website. In 2012, we had our first findings. It was really a success. There was a congress on mathematics and other subjects in DIMES, 2012 in Tokyo. And I held a presentation there that we called Promoting Inclusion in Mathematics and Science in Secondary, Mainstream and Higher Education, because we actually saw numbers of students rising. In 2015, we felt confident and we started to build a new website with a lot of information. Here you see Davy, a photo of Davy. And the next two slides I'm going to show you give you a very short impression of the website we made and the main characters of the notation. First, we substituted symbols. Here, the general ones, percentages stays the same, degrees becomes in Dutch GR, etc. 20 minutes is not enough to give a lot of examples, not important. The other thing is that we did, it was making it linear. And we also, back then, sought for MathML solutions for every notation that we had, and this allowed us one big advantage for partially sighted students to enlarge without the thing becoming vague. It was successful in 2016. I was invited again, and then the title of my presentation was a little more audacious. Math notation used in the Netherlands. Is it a quick fix, or is it a lasting solution? Students and teachers in the Netherlands are quite happy. That is to say, they don't want a math Braille code. The notation works rather fine digitally. It's multimodal, it's communicative, as I said, and Davy is our biggest fan. And we have an increasing number of blind students. Each time that we have a student doing a new subject, we expand the notation. As I said, it was at first for primary and secondary education, and now it also is covering quite a lot of the university math. We will be using MathML in our production line, and yeah, there are still some issues because if you want to render the notation automatically, computers are more strict with spaces and brackets than human beings. So, but these can be solved. Now, I'm very optimistic. I would like to ask you, is internationalization an option? As I said, you see similar challenges everywhere, with expertise falling down, difficult to match. We could easily switch to English substitutions, but, and here comes my question, and I'm very happy that the last speaker is here, and you, or maybe you, it's not a rhetoric question, it is a real question. Do we need a Braille code? Because we cannot print. We cannot print Braille on paper with the notation that the students are used to on their Braille display. Would it allow better learning if we had a Braille code? To make things worse, each student has its own Braille on the Braille display. Because in the Netherlands we don't have a standard A-dot Braille code. So it depends on the table that you have picked in which way your Braille is displayed. Now, that's not in daily practice, it's not a problem because you can train the brain, obviously. The students are used to their own notation, and you type on a QWERTY keyboard, and whatever Braille characters are on the Braille display, as long as you're used to it, it works. It's funny when you're standing here. I see a lot of people here looking very puzzled. This is difficult to imagine, right? Okay. I think actually it would be highly interesting for, oh, I thought 5 minutes, sorry, for a PhD thesis or for research. Most students claim that they cannot do without Braille. Now, what is Braille? Is it a code, or is it giving access? Or what is Braille if it is totally different per user? That's a funny situation. Okay. So is it the Braille or is it the tactile support? Is it the multimodality that is helping the students to understand the Braille? Because they say, I cannot do without my Braille display. Then my working memory is overloaded. Logical. So my question is, and I think we have some time for discussion, do we need a Braille code? What is your opinion? For better understanding, for better learning, for printing? Well, I would like to suggest in the Netherlands, let's just adopt the Nemeth code. It's proven value, and we can print, it's easy to implement. And students can have the same Braille output then on their Braille display and in print, and you can have text-to-speech solutions. And when you work with advanced math programs, if they have math support, there will always be Nemeth. So why not? No more ambiguity or verbosity issues. Original notation is conveyed, is represented. Yeah, now we've got the 5 minutes. Give them some time to think this over. So, please come up with your reactions, experiences, opinions, advices. Is anybody interested in cooperation to get to know more about this or interested in issues?
Thank you so much, Dorine. I think this was a very maybe controversial final presentation, but thanks for bringing up some really important issues.
Thank you.
So, questions? Oh, there's some. Let's go in the back first. Mm-hmm.
Vivian Aldridge from Switzerland. Quick question. If you print diagrams, graphs, and such things, what do you write on them?
That's a very good question. Last year, 18th of March, I remember the date. I had invited a couple of students from university, and they had said, well, that's no problem. We can, because we still use the old math notation that's not being taught anymore, but there is something in our conversion, and some of our old, of the people that draw the images use that. They says, no problem, we can read that. So I gave them the images, and they couldn't read it. I said, how comes? Well, usually they look in the book, and they know what the diagram is about, what is shown, but no, they can't read it. That's one of the problems, yes.
Sky.
My concern would be, how do your students move beyond the borders of your country? How do they access anything beyond their small world if they don't have a code which the rest of the world is possibly using?
I hope I heard your question right. You're asking if it wouldn't be better to have a printed page?
No.
No. Are the students isolated to the Netherlands, then they cannot ever move educationally to any other institution?
Yeah, you're quite right. I had a guest from, I think it was Israel or whatever, and I explained it to her, and she reacted like you. So what are you learning them? So what can they do after? And yes, the transition from school to university is not smooth. That is one of the reasons why I was very active and participating in the ICCHP Summer University for blind students. And they're, well, it would take too long, but if anybody's interested, we try to cope with the problems we meet.
Okay. Our Denmark friend.
Yeah, still awake. So. I'm very much interested in cooperation, Dorine, and also with the other projects about teaching Braille and with a refreshable Braille display and so on. So very many things we could talk about later on.
You made my conference. Thank you.
See you in 3 years. And then, one question about your, because we have the similar challenges in Denmark about. We have solved it differently, but it would also be nice to have one code to rule them all, as we have it with music notation, for example.
Yes.
But how do you handle the situation where the blind student needs to hand in an assignment written in, I don't know what you call normal math, but things with you write the fractions in different levels and so on as they're supposed to be in print. How do you handle that situation?
Yeah, the students can write fairly well with our notation what they need to write. Sometimes there are some ambiguities or what, but in exams or assessments, there often is personal assistance to deal with that type of complex situations. So then they can explain what they mean to write down or whatever.
So they would actually need an assistant to write it out in normal print. if they need to turn it in as a normal,
Yes.
if the teacher can't read the linear system for some reason, or if
Mostly, you can write mostly everything. So
Yeah.
our Davy, our biggest fan, is claiming that he can work with it very well.
well, I hope we could meet and talk afterwards. It would be very
Yes.
great. Yeah.
Yes.
Okay, I think we have a question up front.
Yeah, I have worked with a math system in 2 or 3 different generations in Sweden, and I have university degree of math myself. I must just ask before I made my comment, because do you mean that students in Netherlands should read MFML code on the Braille display? Just so I understand you right.
That's my question.
Yeah.
Should they use a mathematics code instead of our linear notation?
Yeah, but
So in the linear notation,
is your linear notation MFML code?
yeah, the linear notation is very much as you would write in your calculation.
Yeah, so it's not MFML. You're not expecting them to reading MFML code.
No,
No.
no, of course not.
That I'm very happy for, I must say.
No. No, we do hope that we can use MathML in our end products in order to allow text-to-speech. But no, they are not supposed to start reading MathML.
Okay, great. Then I don't have any comment.
Okay.
Okay, other questions? One more? Mhm.
Eric Schmidt from Vienna. In the last comment, you mentioned that the keying in is similar to a calculator. So theoretically asked, isn't this coding? And two questions. How do you key in, for example, per mil sign, or how do you key in square root? And my second question, the students have to use this linear. Do they, for example, make their subtraction or addition or whatever linearly, or how do they calculate?
Okay, there's a lot of questions. Square root, to start with, would be SQR. It's rather verbose, but it's clear. You could also write SQ or wortel in Dutch, but we choose for SQR. And the exponent is the circumflex. And did you add whatever? I could go into detail, but the other question is also interesting. Do they calculate? Do they work linearly? Yes, basically. They have to keep everything in their head, but the Braille display helps as long as the exercise is not more than 40 characters. But it's, in my opinion, and especially also when you look at the younger students, it's not an ideal situation. For the younger students, by the way, we still print the Braille, the math. There are the differences with the standard math notation for literary use are very small. But when, for example, I ask teachers of young children, do you know why we have space, no space after the operator? They cannot tell me. There's no awareness.
I'm sorry to stop you here, but I
Yes.
think we're about out of time, and I'd like for all the speakers to come back up on the stage. Or down on, yeah, that's fine.
So let me say, anybody who wants to discuss this further with me, I won't run away.
So I've been on enough conference committees that I know that many times people say on conference committees, save really interesting things for the very end. And I think this conference committee has done this. So thank you so much for presenting us with some very interesting and very intriguing information. And we have a Fika gift for you. Robert, here's yours.
Thank you.
Thank you. Thank you.